Right, here we've got question 3 for the algebra end of topic test. The first question, we've got to the power of a third there. So that's the cube root. So it's the cube root of the whole thing. It's probably better to split it into two parts. The cube root of 27 and leave the m6 to the power of a third. So then you can find the cube root of 27, which is 9, and multiply your powers. Let's go back to that and just check our answer if I can. Yes. So it is 9m squared. The next one, it's a negative power. So that's 1 over whatever it is in the brackets to become positive. You've got fractions there, so that's 1 divided by that fraction squared. M cubed squared is 10 to the power of 6, and 5 squared is 25. When you divide fractions, turn it upside down and multiply. The 1 is an identity, it will just disappear. There's your answer, 25m to the 6. When it takes a positive whole number, we could call it x, n, call it what you like, squares it, subtracts 6 times that number, divides the result by 4. Her answer is the same as, that's the equal sign, 6 minus the original number. So multiply by 4 to the other side, and we're going to make it equal 0, factorize, and solve it. This method comes up time and time again in both year 12 and year 13, so learn it. When you've got a quadratic, make it equal 0, factorize, solve. Move it over to the left-hand side, factorize it, put in your factors, n equals either -4 or 6. So she must have been thinking of 6 because it was a positive whole number. Next question. This one here is a parabola pool. I don't know what this question is doing in this particular paper, but we'll do it anyway from our knowledge of graphs. Assuming that it starts at 0, 0, where she dives in, and the hoop is standing at 1.5 meters. She goes through the center of the hoop, so she goes through 0.75 centimeters above the bottom of the hoop. Remember, the pool is 3 meters deep. So she surfaces at 5 meters. So using the intercept point, y equals x plus 0 and x minus 5, but we don't know whether it's an out 1, up 1, so we better put a letter there for the scale factor, the letter A, and we'll use the coordinates of the vertex to find out what A is. Now if it's 3 meters deep and you've gone back up 0.75, then it must be 2.25 meters deep. And it's a negative because it's below the surface. So there's your coordinates of the vertex. Plug them in for y and for x. Use your calculator. Calculate it out. Divide by the 6.25 and you get 0.36. Write out your equation again. That's a merit question. Excellence, actually. The next one. This pool is drained to 1/3 of its depth. So that means it must go down to -1. So we've got our equation now, and we want to find where she surfaces at -1. So replace y with -1. Then you expand your brackets, make it equal 0. And for this one, can't really factorize that. So plug in the values on your calculator or use the quadratic formula, and you'll find those two values, find the distance between them, and that's the distance that she swam horizontally. We need to know the discriminant. If it's got no real roots, b squared minus 4ac is less than 0. You better learn that fact if you want to do these sorts of questions. This is an excellence question. A is 2, that's by the x squared. B is by the x, so that's 5m. C is the constant, make sure you include the negative with it. Now plug those values into b squared, which is 5m squared, and you get that. Substituting the green values in for A, B and C. Multiply the second part out and expand your brackets, 25m squared plus 24m. If you factorize that, it's got a common factor of m. And so in this case, m could equal -24 over 25, or m could equal 0, and we want it to have no real roots, so it has to be between those two values, greater than -24 over 5. and less than 0. That's excellence.